Hello students, welcome to the next lecture of the CSIR NET June 2023. Today we will discuss about the complex analysis question which was asked in this paper. Myself Dr. Harish Garg. You can simply scan and join my WhatsApp group where we have discussed the various questions and your queries. Otherwise you can simply follow my YouTube channel Dr. Harish Garg and look at the playlist of the CSIR UGC NET where we have discussed the complete June 2023 papers. The topics are sequence series, integral equation, LPP, ordinary differential, partial differential, Markov chain. All the papers of this June 2023 we have discussed in here. Moreover, we have also discussed the last 12 years PY questions of each topic. So let's start with this question. The first question is you have to find the value of the integral of this. What is that? Radius is 3, center is 0. So this is my here. Then you have to firstly found what are the pole of this. So clearly says this is the equation, this is my denominator. Now clearly says 0 is the root of this, 0 is the double root of this. It means 0 is my pole. What is the order is? Order is my 3. So how you can find the residue of this? You can find that 2 pi iota residue at z is equal to 0. What is the order is? 3. So I can written as 1 by 2 factorial. Second derivative of this one, 1 by z square e raised to power z minus e raised to power minus z. So clearly says it is not an easy task for you. You can take the second derivative of this. So what you can do is, what is the other method is, instead of this you can find the coefficient of 1 over z minus pole is of 0. So you can find the coefficient of the 1 by z from this series. So how you can find the coefficient? So firstly I can simplify this. E raised to power z minus e raised to power minus z. What is that? This is nothing but sine hyperbolic z over 2. So I can multiply like here. This is the here. Then I can expand this series. It's a 2z square. What is the sine hyperbolic z? Z plus z cube upon 3 factorial. Z raised to power 5 over 5 factorial and so on. I can take z as a common, so it is a 1 over 2 z cube, and the rest portion I can written like of here 1 by 3 factorial, 5 over 5 factorial, 4 over 5 factorial, plus and so on raised to power minus 1. Now you can expand it by the binomial. So this is 1 minus 2 over 3 factorial, 4 over 5 factorial, and so on, plus square and then so on. Fine. Now clearly says what is that? I need a coefficient of the 1 by z. So it is already a z cube. So it means I need to consider the z raised to power 2. So what is that? It is first one is not there. This portion, that is a minus 1 over 2 into 3 factorial. This is a z4. It is not be there. Can any term here which is involving z square? No, because it consists of this. When you square them, it is z raised to power 4. So the answer is minus, it's a 6 minus 1 over 12. So what is the right answer of this? 2 pi iota into minus 1 over 12. So it's a minus pi iota by 6 is the right answer of this problem. So you can see, you can simplify it instead of this. Otherwise you can take the second derivative of this. Again you will get the same answer. You can take u over v, you can take the second derivative at the point z is equal to 0. You will again get the same answer. Look at the another one. Consider the function f defined by here such that this is a non-zero. The 90% student usually did a mistake like of this. If I write here, if this function is given as a non-zero, what is the meaning of that? Student may think this can never be 0. It means they have no pole. So once they have no pole, it means it is a analytic function, or you can say it's the entire function. Then student can take this option. But remember, this is not the right way. What is the meaning of this? If you define the function like of p by q, we usually define the function, the fraction, when denominator is a non-zero, because here it is written as z belongs to the c. So definitely, what is the meaning of that? You define the c minus of the when the denominator is 0. So now look at that. If I write this function as 1 over z minus alpha, z minus beta, where alpha and beta are the roots of this. So clearly says because z is belong to the complete C, So alpha and beta is also the part of 6. So therefore alpha and beta are my pole of the fz. So once this is the pole, it means f is not entire. Fine. So you can see this option is cancelled out. Now you can check whether 0 is the pole. So what is the meaning of the pole is, if I say z is equal to alpha is the pole, what is the meaning of that? If I substitute alpha in the denominator, then equation becomes a 0, then alpha is the pole. If I take z is equal to 0 here, it becomes my 1, which is non-zero. It means 0 is not a pole. So this option is also cancelled. Now look at this third and the fourth option. If you look about the third and fourth option, this is a very similar option. That is a Taylor series. And they are talking about this. This is again similar. We don't think about that. A0 is similar. Only the difference is A1. How you can find the A1? That is, we all know how you can find the coefficient of an, that is the nth derivative at the center. What is the center of this series? 0 divided by n factorial. So what is the a1? First time derivative at the point 0 over 1 factorial. So what is that? F of z is by 1 over this. What is the first derivative of this? So minus 1 over whole square into minus 1 minus 2z. So if I take the first derivative at the point 0, so it is 0, it's my plus 1 over 1 minus 0 square, it is plus 1. So a1 is my plus 1. So a1 is a 0, this option is cancelled. Only the remaining option is my correct answer of this problem. So that's a simple target, that's a simple question about this complex analysis. Okay, look at the another one. F is given to be the entire function such that f of z is less than equal to e raised to power y. This is given to you. Then which of the following statement is true about the fz? It's so very simple. There is no need to solve the problem. Look at that. We need e raised to power y. How you can get e raised to power y? For example, if I take this second option, e raised to power iota z. If I open this z x plus iota y, what will happen? This I get as a minus y, but we need a plus y. So it means this option is definitely cancelled. Similarly, this option is also cancelled, iota y. Look at the third option, e raised to power c iota x plus iota y, because z is here. If I open this, c iota x is a separate into cy, but we need as a only c. But you may think that c mod of c is less than 1. That may or may not be the correct answer. Look at this option first, c e raised to power minus iota x into minus of iota square y, that is c e raised to power this of ey. So that is there. So it means the first and the third, it may be the right answer, but only the one correct option is there. So I can start with the first option. So this is my f. If I start with the modulus of this, what is that? This is mod of c, mod of e raised to power y. So since this is a real number, so what is the mod of the real number? It is always the positive. So this of ey, this is my f of z, and it is given that mod of c is less than equal to 1. So this is less than of e raised to power y. It satisfied this property. This is the right answer. If you look about the third option, this is the third option. So if I take the modulus of this value becomes a 1. This value will be here, which mod of c is less than 1. It doesn't implies that it is less than of e raised to power y, because c can be anything. If c is my 1 by 2, c is any of this number, c is any of the complex number. If I take c as my iota, then definitely this will be the cancel out. It's a 1. It is not of e raised to power y. So this option is also cancelled. Right option is only my first argument. Moreover, there is no need to solve the problem. You can think about first, second and third we already discard. In this case, c is my any complex number. If I simply take c is my, which satisfied this, I can simply take c is my iota. Fine. So if I take c is my iota, is complex is also less than equal to 1 satisfied. What is that? E raised to power minus iota square z. This is e raised to power z. Again you can see this is e raised to power x, e raised to power iota y, but we need as e raised to power y. So this option is also cancelled out. So only the one option is left, which is as a first is the right answer. Otherwise you can solve like this. Otherwise you can simply take the option and get the right answer fraction of second. Okay, look at this another one. F is the mapping from, if I call this is my A, this is my B. So F is the mapping from A to B. What is my A? Is a unit circle, open circle. Z is my 1 and B is my half. Fine. Okay, so that's fine. This is, and it is also given that f of 0 is 0. Which first thing come in your mind when we always think about f0 is 0? Schwarz inequality. We always think about this Schwarz in lemma. What is that lemma suggested you? This is always be less than of this, and the nth derivative at the point 0 is less than equal to n factorial. That is a Schwarz lemma is there. Now we can think whether it's a usable or not. F of 0 is 0, that's a Schwarz lemma. So you can see the first property satisfied. F of z is less than equal to z by using the Schwarz lemma. There is no derivative involved, so there is no need of this one. Look at this one. F of z is less than of z by 2. Now what is the z? This z is belongs to the A. So what is that? In the A, what is given to you? It's z is strictly less than of the 1. So I can say z is strictly less than of the 1. It is less than of 1 by 2. And what is the B? B is here. So f of z is less than of this. Obviously, because this is my codomain. So what is the meaning of that? Whatever the value of the fz is always be less than or equal to the range of this B. That is less than equal to half. So you can see this is less than equal to of half is right answer of the problem. Third one is by the definition of the function, that is the domain and the codomain. Any element taken from the domain f of z, this is the element of the A, is less than equal to the domain of B. F of half is half. That is not always true. This is true only when you have the two distinct elements, let's say f of this and here, where alpha and beta are my distinct element. Then only you can say f of z is my z. But here there is only one point is given to you, f of 0 is 0, but there is no other point given to you as here. So you can't say it is always possible. It is never be here because this condition not satisfied. So the right answers are 1, 2 and 3 are my correct options. Okay, which of the following is the correct statement? Is a part C or part B? Fz is the entire function here. Can you think about any of the entire function? What is the meaning of the entire function? How you can check that? If derivative of this f is non-zero, then it is not entire. Fine. If it is a 0, then it may or may not be, but if it is a non-zero, then definitely it's not be the entire. Or otherwise you can satisfy the UV conditions are there. Cauchy-Riemann conditions are there. So look at that. Think about any of the entire function. This is the entire function. This is the entire function. So I can take the simplest one as f of z is my z, which is my entire function. Now you can think about the first option. What is that? F of z bar. So what is the first option is here. So clearly says the f of z bar is here. What is the partial derivative of this? Is my 1, which is non-zero. If I consider this is f, what is the partial derivative of this f is 1, which is non-zero, then it is not an entire. So this counter example will discard the option. Look at the second option. This is z bar. If I consider this is f, so what is the partial derivative of with respect to z is a 1, which is non-zero. It means it is not an entire function. Look at the third option. This is the complex conjugate of here. What is that? This is z. And what is that? If you take this is my f, partial derivative of this, it's a 0. So we can't say that is whether it's an entire or not. Look at the fourth option. This is z bar plus this is z bar. So what is that? This is 2 of z bar. So if I take the partial derivative of this is my 2, which is non-zero. So it means this is not an entire. So since all the 4 options, all the 3 options cancel, so remaining one is only 3. So I can say this is third is the correct option. That's a very simple question. Okay, look at this another one which is related to the part C. paper ID 40. What is given to you? D is my domain from the circle, unit circle, radius 1. Consider the following statement A, B, C. F is my holomorphic function. Alpha and beta are my distinct root such that f of alpha, f of beta is my beta, where alpha and beta are my distinct root. Then as I earlier told you, when alpha and beta are my distinct root, then f of z is the correct statement. This is always correct. Make sure f should be the analytic function, and it is given that. So it means the first is my correct option. So both A and B are false. This option is cancelled out. Now A is true. This option is correct because this is the part C, maybe more than one correct option. So we need to check only the B, because if B is my false, this option cancel, and C also. Okay, there does not exist a bijective map from D to any complex number whose imaginary part is, if I call as here, this is my u plus iota v, where what is the condition implies to you? Where imaginary part is my positive. This is given to you. So he said there is no bijective map given to you. That's a wrong statement. We all know, if you remember your Riemann hypothesis, Riemann mapping theorem. If you have a Riemann mapping theorem, if you have a holomorphic function and this is my open set, this is my open set, then you can define always a bijective map. He said there does not exist a bijective. So if I prove that there is a one bijective map, that statement is false. But by using the Riemann mapping theorem, there is always exist a one bijective map whose condition is V is satisfied. So this statement is my false statement. So B is my false. So this option is also cancelled out. Now look at that, whether C is my correct or wrong. D is my holomorphic. Alpha belongs to the D such that f of alpha is alpha and derivative of alpha is my 1. Then your target is to prove whether this property is satisfied or not. Look at that. Alpha is my D. Alpha is any number. So you can choose any number in the D. If I consider alpha is 0 for the simple one, alpha of 0 is 0, f dash of 0 is my 1. Fine. So now again think about that. Whenever f of 0 is given to you, which lemma will work? Always Schwarz lemma. So what is given to you? F of z is less than equal to mod z, and nth derivative here is a 1. So first derivative will be less than equal to 1 factorial, that is 1. Now look at that. In this case, equality appears. In this case, equality appears. That is, maximum value occurs at alpha. Alpha in this case 0, and here f of 0 is 0. Again equality appears. So what is the meaning of that? Its equality appears. So by the maximum modulo principle, you can say f of z is the right option. Otherwise you can think like here also. If I just clear this one, what is that? F of z is less than equal to z, and first derivative of z is 1. And here you can see the equality occurs at this point. So once the equality occurs at this point, the maximum value occurring at this z is my 0, or maximum value occurring at this alpha, because this is my here. So what is the meaning of that? You can see if this is the equality occurring, then this is also equality occur. That's by using this Cauchy-Schwarz inequality, or you can say Schwarz lemma, or you can see also by here. So this is also my correct statement. So this is my right answer. So correct options are 2 and 4 are my correct options. Look at this another one. For the function f of z is e raised to power z plus 1 over z, you have to find the residue at z is 0. So again, how you can find the residue? So that is, you have to find the coefficient of 1 over z. So how you can find the coefficient of the 1 by z? I can written like here. I can expand the exponential series, z square upon 2 factorial and so on. This is 1 plus z plus 1 over 2 factorial z square and so on. Now look at the coefficient of the z raised to power 1 by z. The first term will comes here. This is coefficient is 1 over 1. Any other term? No. When you multiply this z, it becomes my here 1 over 2 factorial. When you multiply this, it will comes my 1 over 3 factorial z cube. So when you multiply them, it is 1 over 3 factorial 2 factorial. When you take as a z cube over 3 factorial, here is 1 over 4 factorial z raised to power 4. So 1 over 4 factorial, 3 factorial and so on. So I can return this as 1 factorial as well. So what is that? This is L factorial, L plus 1 factorial when L varies from 0 to infinity. When L is 0 is a 1 factorial, when L is 1 is a 1 and 2 and so on. So L factorial, L plus 1 factorial, L factorial, L plus 1, L factorial, L plus 1, L square cancel. Right option is my third is the correct answer. So this is the way you can solve all these complex analysis question. So I think very simple complex analysis paper is there in this June 2023. I hope you can simply learn these various tricks about this complex analysis. You can simply like, share and comments on my video. Share with your friends as much as possible. Thank you very much, students. Happy learning always.